welcome to this Ivory Egg introduction to KNX. My name's Mark, and in this quick session we're going to have a look at what KNX is, how the system's designed, how it's programmed, and some key applications. So what is KNX? Well, it's a standardized protocol that's been around for 30 years that allows products from different manufacturers to work together to control a building. There's over 490 manufacturers that all are part of the association, and using their products you can control heating, lighting, AC, shading, metering, monitoring, anything that might be happening in a building. In this example we can see a power supply at the top which powers the bus. That's from one manufacturer, and then we've got a PIR from another manufacturer. That PIR is going to detect motion, it might be reading temperature, then it'll be sending a signal onto the bus saying there's activity. That signal then can be picked up by a manifold controller, which is at the bottom of the screen, or a lighting relay. All these different products can all respond to the different messages happening on the system. It's completely decentralized. No product is reliant on another. They all have the intelligence to be able to perform their functions. So if we have a keypad in the system, that will have everything it needs to be able to send different signals. It might be turning a light on and off, it could be sending a temperature, it could be changing the color temperature of a light. Everything is integrated in that product for it to perform its function. When a button is pushed, it sends a telegram on the bus, which other products will pick up. Because of the standardization, no manufacturer really controls the code. That's handled by the KNX Association. The way the system works is always the same, and we've got 30 years of backwards compatibility in terms of products working in a building. Because of that, it provides one of the best platforms for installation in a building, because you know that the system you're installing is going to be around for as long as the building will last. And because no manufacturer can change how it works, you're given assurance that the system is set for the future. So let's dig into the system a little bit more. There's a couple of different communication mediums. It can exist over IP, it can exist over RF, but the main KNX system that people recognize is a wired system. In a wired system, you have a pair of cables, a red and black, that powers the devices and also provides the communication. Everything happens on that red and black, and generally products use the Vargo standardized connector, which means it's really easy to install, and one of the real benefits is you can disconnect a product from the bus without affecting the operation of the bus. So if you're working in a large commercial building where you need to have 100% uptime, but you need to replace a product, it's very simple to do with KNX because the product isn't hardwired into the bus. It's quite common to see a two-pair cable used though, where we'll have a yellow and white. That's often used for products that require additional power or can provide some redundancy in the cable, but the actual bus communication happens over a red and black connector. One of the real benefits of the cable and the system is it's designed to be run with mains. The signal on the red and black is a symmetrical signal, so it is immune to interference. So the KNX control cable can be run with the electrical installation, which is where it should be. We need a power supply on the line. Now this is a specific KNX power supply because it has an integrated choke, and it's the choke that allows the AC signal and the DC signal to be on the same cables. It also forms part of the telegram, so it's a really important part in the system. So KNX power supply, that powers the bus and manages some of the communication. There's lots of different versions available. The most common one would be a 640 milliamp power supply. Now the size of the power supply is determined by the power requirements of the devices on the bus. It's really important to check that and make sure you're providing enough power in the normal way. KNX power supplies are really, really well engineered. They're designed as a central component in the system to be extremely reliable and have a very, very low failure rate. And you can tell that because of the size of them. They're over-engineered to ensure there's a large amount of heat dissipation, so they just don't fail. They're a very solid device. So we need to know we need to size the power supply for the number of devices, but what about the actual system device limits? Well, the topology in a KNX system can go from a very small line where you may have a power supply and two devices, all the way up to a very large system with 61,696 devices. And we do that by having different topology layers. So on a line in this example, we have a power supply and 255 devices. Now that's the system limit for a line. The actual number of devices will be determined by the size of the power supply. If we need to go up and add more devices, well, we add a coupler. And a coupler manages the flow of traffic. It keeps local information local and doesn't share it with the rest of the system. But if there's a system-wide message, then it will pass that through up or down through the topology layers. And that means that the system is broken down into individual cells, which increases that reliability. If something did happen to that power supply or happened on that line, it wouldn't affect the rest of the system because the coupler is linking things together. So from a line, we can add a coupler, and that will create an area line or a main line. From that main line, we can have up to 15 lines. We can then take that area and we can go up another layer and connect that area to a backbone line. That line can have 15 areas hanging off it. So we can have 15 areas, each of them with 15 lines, and each line can have 255 devices. Now, any of those layers could actually be IP. So we could have a twisted pair line or area in different areas of a building with a IP backbone linking everything together. Maybe it's a large installation site like a university where you have a lot of different buildings. With the KNX system limit being so large, there's very few projects that KNX wouldn't be applicable for. Now that leads people to say, well, with the system being so large, surely there's a lot of overhead in that when you're designing small systems, maybe a small residential installation, working with such a large system, there's adding complication and cost. Well, it's just not true with KNX because of that decentralization. Because you just need a power supply and the devices you need, there's no central servers, every little device has its own intelligence. There's no additional cost. If you've got just a keypad and maybe an 8-channel relay, and you need a small power supply, those 3 devices are all you need in the system. If you want to increase the functionality or increase the size of the project, you just add the devices you need, which means KNX is applicable for loads of different projects. It could be small residential, it could be commercial, it could be offices, it could be medical used in hospitals. It is very, very powerful in that sense. And the topology ensures that you get the most amount of reliability and resilience built into the system. So now we know about the power supplies and the topology. How do we program it? Well, everything is done through one software. Because there's so many manufacturers, we can't have them all developing their own way of programming it. The KNX Association manage the ETS software, which is currently version 5, which all manufacturers have to create driver files for the programming to happen. So from one software, you can configure large projects, small projects, it could be an HVAC project, could be lighting, everything happens in one place. And the real benefit of that is you don't need to retrain for different types of projects. Everything is always in the same software. You can get really, really competent with the software, knowing that your next 5, 6, 20 projects, they could all be different types of projects, different size projects, or doing different applications, and you're always going to be using the same software. There's no jumping between different manufacturers or changing solutions. Now, it really is designed for professionals. It's a very powerful software, but there's a huge amount of features in it which enable you to make things simpler or easier, or program in faster ways or slower ways. It's constantly evolving, huge amount of updates done by the KNX Association, and ETS really captures what KNX is. The ability to program a huge range of products from different manufacturers doing different functionalities, but always being updated, adding new features like KNX Secure, which enables us to encrypt both the messages on the bus, but also the entire IP layer if we're doing an IP KNX backbone, for example. So adding these new features means that KNX is always kept up to date, but we have this look back in terms of backwards compatibility with previous versions of the system. So using ETS 5, there's 5 steps to programming. The first is to create a project, and that one's really easy. That's just clicking create a new project and giving it a name. We then add devices to the project from the online database. So as a manufacturer develops products, there's a driver file which has all the information about how that product works. That exists in the online database. You just drag it from there into your project. So again, a really easy step. You then configure the individual device parameters. That's where you define what a product does. It might be a 6-button keypad, and you want one button to call a scene. You want another button to do a raise lower, so push to turn on, push and hold to dim up, for example. You might have another button changing the heating mode in the building. And the parameters is where you configure those settings for each of the individual functions. We then link the different devices together in a group address. So we just take an object from one product and link it with another in a group address. Now, group addresses are the main runtime of the system. If you looked at a KNX bus when it was working, you'd see a lot of group addresses. And they enable all the different products to talk to each other without needing to know about each other. Once we've done all that group address configuration, we then download to the devices over the bus. So we just connect an interface, which would be either USB or via an IP interface. Select the device and download to it. As simple as that. So just looking into that group address configuration in a little bit more detail. Here we've got an example with two products. We've got a keypad and we've got a relay. Once we've configured the parameters, we take an object from each of the things we want to control. So we've got the rocker object from the keypad. We drag that into a group address. This group address is called 1/1/1 living wall lamp on off. So we've taken the switching object into that group address. So when we push a button, it will send a value of 1 to that group address. We then add the object from the relay into the same group address. So when it receives that group address, it will look into it and see what value it is. It has a value of 1, so it will know to turn on. Now, the beauty of this is, if we wanted that same button to turn on all the lights in the property, it could be 100 different fittings, it could be 1,000 different light fittings. All we would do is add the objects from the relays into the same group address. So using one group address, we could turn on everything in a property. One message being sent on the bus could achieve, a massive amount of functionality with a lot happening. So whilst it seems like there's a lot to configure because we're doing all these individual group addressing for all the different functions, actually there's a lot of crossover, and it is one of the key strengths of KNX is the simplicity in which we can control many, many devices. You want to have a button by the front door that turns all the lighting in the property off? Well, that could just be one simple message on the KNX bus. Right, so now we know how to program, let's look at some products. And one of the real strengths of KNX is the range of different keypads. With so many different manufacturers making products, they all have their own different design intent. Now I've chosen 6 different keypads here, really with the goal of showing the difference between them. They all have either 6 or 4 buttons, and they're all going to be able to do exactly the same thing in terms of options on how you would control something. But they all look massively different. It could be going from a metal finish to a glass finish to something with, real solid buttons, so it's clear what the surface you need to push is, something inscribed, huge range of options. So if you're sitting with a customer or you're looking at the interior design of a room and you're trying to work out what you want it to look like, KNX gives you the flexibility to choose a design that suits the interior design, but you don't have to compromise on functionality. And you're never worried about, having to change the system you're using. On one project, you could be doing a completely different design to another project, but you're using exactly the same system and programming it in the same way, which is a real benefit. So it's looking at some other products. One of the ones we see a lot of is PIRs, so a detector in the ceiling that's, you're seeing motion in the room tied into the lux level. So depending on the brightness in the room, it will turn on the lighting, but also could be used to enable heating. And that's where we're getting this cross functionality, because everything is on the KNX system, everything is controlled by one system. It's really easy to have crossover. So PIR turning on the heating or disabling the heating when you're no longer present in the room. It's really simple to achieve. We could be using a more intelligent sensor that's able to determine, this is an outdoor detector, which is able to determine the direction of travel. So it will know if you're moving towards the building or away from the building. So then we could start to activate, different lighting. It could be driveway lights turning on as you come towards the property. Or we could start to get really intelligent and say, well, we know there's no motion in the property. We know the time of the day means no one's going to be asleep. And we know you're leaving the property because you're driving away. Well, we could use that to shut down the heating, for example. The possibilities really are limitless. This is a dimmer, and the quality of dimming we see in KNX is huge. And one of the reasons is we've got so many different manufacturers making products and effectively competing with each other. So one manufacturer might bring out a dimmer Another one might bring out another one. It needs to step up in terms of functionality for them to stand out. We've effectively got 490 different manufacturers, all with their own R&D budgets, investing in the development of products. It's not just one manufacturer and what they feel is the right product development. We've got such a wide range. We really see constant innovation and change. So mains dimming LED, for example, really, really high quality dimming because of that strength of KNX. Manifold controllers, underfloor heating, for example, really, really simple to control and just sitting on the same system as everything else. So huge range of different products for heating control, and radiators, controlling valves, or it could be controlling air conditioning. A little interface unit that sits in the AC unit and communicates directly to it. So we've gone from having lighting control through to different types of heating, and now we're bringing in air conditioning. Everything working on the same system and programmed together at one level. We can even introduce visualization, app control, remote access control, or adding additional logic to the bus using a server module. Doesn't replace the decentralized nature of KNX, but sometimes you do want a little bit more processing power in one place. So it fits within the KNX architecture in terms of every product being individual, but provides you things like remote access or additional functionality. Some more like weather stations enable you to do, facade control of shading, where you've got, if you know the sun position, the brightness level, you can then control the shading to manage the internal temperature, reduce solar gain. It could be CO2 sensors, doing more environmental sensing and knowing, what the internal air quality is, and using that to open windows or increase ventilation. It could be going from a dedicated CO2 and humidity sensor, as this example, all the way up to a full room controller, which is able to read not only the humidity and the CO2 level and the temperature and lux level, but also bring in, VOC. So you're really getting into air quality, and you can start to really manage that internal environment. Being able to bring metering into the system, be it a water meter, gas meter, or electric, interfacing to different metering solutions, enables us to use that data as part of our control environment. Yes, we would visualize the metering data, but actually being able to say, well, we've got water flow. We shouldn't have water flow because of the alarm set, which means the building's unoccupied. It's been more than 12 hours, so you've left the property. So let's notify the customer that they've got a leak. And let's also close a valve to stop the leak and prevent any damage happening. So using metering provides us with a lot more information and way to control the building. And that's even more apparent when it comes to things like, renewables, generating solar, storing that into batteries, and being able to make decisions on which energy you're using or when you're using the energy is it's something we're going to have to get a lot better at to deal with the climate crisis, climate change. So KNX provides a really good solution to that because it's already offering control of all the different parts of the building. Integrating to other systems like DALI, using DALI for your lighting control, which provides real feedback on the status of different fittings, doing things like color temperature control, or working with emergency ballast so you can automate the testing of emergency lighting in commercial buildings. Really simple with DALI, and KNX provides a great backbone to integrate that into the rest of the building. Or doing things like fan coil control, more advanced HVAC applications. It could be chilled ceilings. It could be interfacing to different BMS systems like BACnet, Modbus. There really isn't a limit to the different functionalities within KNX. So why KNX? Well, it's a very, very flexible system that has applications in a huge amount of different projects, be it residential, be it commercial, different types of commercial buildings. It can be used on all of them, but you're not carrying any of the overheads from one to the other. And that flexibility means that as an integrator or as a systems designer, you can approach different projects knowing that you've got a system and a solution that's going to enable you to offer a solution. You're going to be able to find a way to control this product and this project. And when the customer throws a curveball like, we want to include irrigation control in this property, KNX provides such a strong platform that you're going to be able to find a solution. You'll be able to just get the products that offer irrigation control, integrate that onto the one system through the whole property, and you're done. The range of interfaces is massive, and it is a real driver for, particularly in residential, for why KNX is so successful, because there's always a different design to suit the interior design. It's been around for over 30 years. There's over 90,000 integrators worldwide. There's training centres in pretty much every country. It is a very, very established system. And that recognition means that you're working with a system that's going to be around for a long time. And it's something that you can invest in, knowing that the system itself is designed for for any type of project, but also isn't going to go away. So as an integration business, it gives you a huge amount of assurance that this is a system that's going to be here for the future. And if you're a customer, or you're looking to install this in your building, or a facilities manager, you're wiring something into the building that is designed for the future. It's not just a happenstance that it's going to be around in 10 years. The way the system is designed is future-proof in its very nature. And a lot of that's linked to that standardized open protocol. You're not dealing with one manufacturer, you're dealing with a huge range of manufacturers, and you're dealing with a protocol that enables the different products to work together. So if you need to change how the building works or change the types of products, KNX gives you the flexibility to do that because of that standardization. And ultimately, it's one of the real strengths is it makes buildings more intelligent. It makes them more efficient, makes them easier to control. It makes everything that we expect of an intelligent building, it makes it possible. You're able to integrate all the different functionalities in the building, use all the different information that we get from the internal environment and the external environment to make decisions about how the building should work and how to best create that really nice internal environment. I hope you found this video informative. Lots of different videos on the YouTube channel, so please subscribe using the link below or on the little button. If you've got any comments, please post them below and we'll get back to you as soon as we can. Thank you very much for watching.